Hi everyone, welcome to the first episode of JE Software Creations. I'm Joao. In this episode, we're going to have a look at how to create a coroutines-based reactive application. So let's get into it. So, we are going to be creating a spot-on app. This application will allow users to save in database their favorite articles, their location, and where they're at. So that's why it's called spot on, because the articles were spot on enough to be registered in the database. So it's just an example, and what we need to realize is that first we need to have a good idea of the data model we're going to use, even before we start thinking about anything related to Spring Boot or coroutines. So let's do it. In the YouTube sessions folder, it's still empty, and it doesn't have any project because, of course, this is the first episode. And let's now just create a folder where we can set up our projects. So I'm going to create a spot on folder, spot on, and now here we're going to create a README file. So let's think a bit about what we want to include in our project. Let's get this out of the way. So the model of our project essentially contains a couple of types of requests. So it will be interesting to create a post, a put, a patch, a get, and probably a good idea also to include a head request in our application. So we are building a REST application by all means. So what is the model that we are going to create? So let's see. We're going to create a JSON, and so the JSON, what will it contain? What we need to keep a record of our favorite article on the web, the one that's spot on. So let's see. We need the URL. So let's make the URL. And the article will be located anywhere, but just for the sake of example, let's call it localhost 8080. Let's call it my favorite article. Then we need to give it its name. So name, and then it will be, I don't know, something that we really like. Could be, well, I like coffee, so let's say something about coffee. Hey, why not how to brew a coffee? How to brew coffee at home. How about that? And then we're probably going to need just a small teaser for the article. So let's say intro, and say something like, have you ever spilled the beans? Something like this. So it's a short introduction. Let's say maybe we can then put a maximum to it, but for now let's just leave it that way. And then what else would we need as data when we are posting? Well, we don't need it yet, but we might want to register the date where this was, the date when we sent this to the database. So not here, but definitely in the data model. So we can say something like that our entity will have parameters, then we'll have type, and then let's say something like this, and then let's say, alright, then we have URL, should be just a string, for example. It's just pseudocode so that we really have an idea of what the application should do. Then we have something like a name, and the name can also be a string, also not really limited. Intro should be limited, so let's say it has 50, call, maybe, yeah, we can use already SQL SQL code, so varchar, I don't know, 50. Let's say a maximum of 50 characters should be enough, and we will also validate that with our REST application. Finally, we will need what is also always very important in the entities. So this is database entities. So we're going to say that this is the ID, and the ID will be a UID. So then we have a good idea of what kind of model we want. So, there's something that needs to be fixed. Okay, so yeah, there we go. So this is our database entities. All right. So having done this, we can now say that this whole thing is part of our domain. So we can say that this is part of our domain, and we have the DTO, and here we have, of course, the database entities. So if we look at here what we actually have done this, it's very, very quickly. We've determined what the DTO is, and we've determined the entities of how we want it to look like. So our REST application just have one entity, just have one type of records, and now we have to define what we want to do with these REST entities. So for the post endpoint, we want to make sure that we are posting our records. So essentially we are actually just send new records. For the put request, we're going to say changes records. And for the purpose of this application, we're going to allow the change for all records. The batch request will be about just changing one request and one request only, and that is the URL. Just changes to the URL. Why is this important? Well, articles do change their locations, probably because the author wants to change the publisher. Maybe there's been some litigation, some issue, we don't know, but the point is articles do change their location, and they can be also replicated in many locations. So we may want to change the URL simply because we bumped into a location of the article that shouldn't even be there in the first place. So finally, of course, we need to get the records back. So we're just going to read all and read per ID. And finally, we're going to have a head request where we're just going to exchange metadata. So all of this together makes our spot on application. So let's start creating our application. One of the alternatives to create an application is usually, we can create our application manually, but we can also use start.spring.io. So I will show that to you. Start, let me just put the Google page so that you can see what I really want to do. So there we go, put it like this. Alright, so let's search for start.spring.io. Here we have a great page by Spring, and in this page we can configure anything we want for the for the foundations of our application. Now, the foundations of our application really is divided into many different segments, as you know. One of the key factors is the package manager. So which package manager do we want? We should create one that it's really modern. So today is hip and happening to use Kotlin everywhere and to use Gradle. So let's select Gradle. Let's select Spring Boot version 3.03. Let's select Kotlin as the main language, and let's use the group called org.jsperacinha and use as an artifact name the spot on app, and as name we'll use spot on. We want
to name this application, give it a description. For the description, let's just say it is an application that will allow us to see the use of coroutines. So let's say coroutines example. There we go. So coroutines example, we have everything right, but there is one thing off, and that is the package name. We don't want hyphens in our package name, so we just say dot. So, and for the Java version, let's select the Java 19 version. Let's just double check. Gradle Kotlin 303 jar 19. Alright, so now let's add the dependencies. As I mentioned before, we need to have a reactive application, and for that we have Webflux. So let's just add it. Now we need the database, and the database is going to be H2. And then we also need the database connection, and that is achieved by R2DBC, which is a sort of database connection that has things in common with JDBC, but allows us to connect to the database in a reactive way. So no blocking processes while we access the database, or at least a minimum amount of processes will be blocked. So we seem to have everything configured. So now let's generate our spot on zip file. There we go. Let's go and show it in a folder in our downloads folder. Let's copy that file and let's copy it to our IntelliJ. Let's put it here on the root. So let's not add it to Git. And now let's just open another terminal where we are right on the root of all our projects. So let's now unzip the spot on zip file. There we go. And then we have the whole project, which we can now allow IntelliJ to compile. The reason why it's not compiling is because I've already made a version before which didn't allow it to work. But if we build it again, then we will finally have a project that's perfectly compiled, and we can also see that we already have some sort of application that seems to be runnable. So let's run it, let's start it, and as you can see, the application is starting, and we do have an application that can start and has Netty already starting on port 8080. So this seems all good. Now let's stop this. Now let's compile our project with Gradle. So that way we're making sure that whatever we find on the command line is a truly built project with Gradle. So let's go to the terminal, and on terminal, let's go Java jar build, Java jar spot on, and then build, and then libs, and then finally we go to this one. So this is the final compiled jar. Let's kick it and start it. There we go. So we have a runnable executable jar file in the command line that we started via the command line. Let's just first delete the zip file as we don't need it anymore. And now what we have is our, we've seen this before, so it's our application. Let's now add our repository. So let's start by creating a package. So let's create a package. Let's call it repository. Or actually, a best name for it would be domain. There we go. There's domain, and then we create a new class. Well, in this case, let's just create a file, a Kotlin file, and let's just call it domain. There we go. So we have domain. Now let's go back to our model for a bit, and let's put them side by side. Let's go here to the README file, which is still in spot on, and let's just put it in a spot on module. So here we go, and then we've got this file. Let's put it here at this side. So now we have a side-by-side visualization of what we want, and then we have here the all the information we need to create the first entity. So let's do that. Let's begin from the beginning. So we've mentioned that we need a coroutines repository, right? So The way we are going to develop this application is a bit in a trial and error fashion. So we're going to make runs and see what works and what doesn't work. So let's start from the base. We need entities, right? So we need data, a data class, which is we'll call spot on. A spot on class will have a URL. It will have a name. It will have an intro. And it will have an ID. Well, the ID, to make the code more beautiful, it's going to say that I'm going to use as the first parameter, and we're going to say ID, URL, name, intro. All right, so now we have this. What else do we need? We need a repository, right? So let's create a repository. Let's create interface spot on repository, and now we need to extend our repository from a CRUD repository. CRUD repository we are going to use is a different sort of repository. It's called a coroutine CRUD repository. So instead of extending from a CRUD repository, we extend from coroutine repository, which has an entity called spot on and uses UID as a primary key. So this concludes a part of the, and now we have to extend our repository from a CRUD repository. Which CRUD repository we are going to use? Well, we're not going to use this CRUD repository. We are going to use a coroutine CRUD repository, which has an entity called spot on and a UID as the primary key. This concludes our data access layer. Now let's go to the business layer. And the business layer is, and we'll define our business layer in the service package. And the service layer will have a Kotlin script file. And we can name this file as service. And here we'll create a class called spot on service that will be injected with a spot on repository, which will allow us to call different methods to perform different CRUD operations in our database in a reactive way, of course. So what we need to do now is to create a function that will allow us to insert records and to update them. But first, before we do any of that, we are still missing a DTO. The DTO is what we are going to get from the controller. So the DTO is used in the model as part of the business layer. So we create a spot on DTO class that will contain the same parameters as we have in the domain. So we can just copy paste them to the service layer, and this is part of our model. Now we need to add functions, of course, to our spot on service. So one of the most important functions is an upsert. Still, not yet, because now we need to create converters. So we can create extension functions for our converters, and here we can create a toData converter, which will be just the instantiation or the creation of a spot on instance, where we will say that the ID is then the ID. It's very, very easy. So URL is this.url, and this name equals this.name, and intro equals this.intro. Okay, so we have the toDTO. We will also need to, wait a minute, we also need to convert it back. So that would be fun spot, so that would be fun spot on dot toDTO equals spot on DTO, and then here we'll just copy paste it because we have exactly the same properties. So now we have now we have toData, toDTO, and here we'll create the upsert function that will receive a spot on DTO, spot on DTO, and it will use the spot on repository to save spot on DTO to data, and it will return to DTO object. So now we have this. It is still complaining about something, and that is that the save, as you can read from here, must be a suspend function. And this is where things become very coroutine-like. Suspend is a way that the Kotlin framework and the Kotlin library and the standard library have to let the compiler know that these functions are being called within the coroutine scope. So what this means is that when we cannot trivially call this function anymore. This function will always have to be called within a coroutine scope because this function is actually itself a coroutine, and that's what you see here uh, in this sign here. This indicates a coroutine. All right. So now that we've done this, all we need to do is to mark our service with the annotation service, and we can now move on to the controller. So let's create our controller layer. So controller, and the controller will have just another controller Kotlin script file, and here we'll create, of course, you probably have guessed it already, a spot on controller. And what will the spot on controller have? Well, we know that it is a REST controller. We also know that it needs to be on the root. So we're going to create a request mapping for it. And here we're now going to create the first post request that we're actually going to need to access our application and post some spot on articles. So post spot on. What do we receive here? We receive a request body, and this is going to be a spot on DTO, which will then call the service. Now, we need to add the service to our controller. So val spot on service, and now spot on service dot upsert spot on DTO. Why is it complaining? You've guessed it. It is complaining because this is not a suspend function yet. If we do this, then we have a suspend function. If you remember when we created our foundation project, we have added webflux to it. And we have said that we are using the Kotlin library, and these two together mean that the project is generated with the use of a few libraries that are important to be aware of. We get project reactor in the coroutine form, and we get Kotlin reflect. These two are very important to be able to serialize and create mappings between JSON and the different instance types that we are creating. In this case, we are just creating one, and that is this one. So this is important to know because we have to be aware that we are creating a coroutine-based application. So everything that's being done here is reactive, and the reactive implementation is made possible, in this case, using coroutines. So now we have one post. Now we can very easily play with this application. So let's now make the GET request. In order to make our GET request to work, we need to go back to the service layer, and here let's make the calls to retrieve all current spot on articles. So how do we do this? Do we create a suspend function? Well, we are going to get all articles. We are going to get a list. Are we going to get a list? We probably are not going to get a list, and we probably are not going to need a suspend function. So we're going to get all. So we're going to get all records. So let's go to post spot on repository. We're going to find all. If you noticed, we are not getting a list. We are getting a flow. So flow is a way to stream data out of our service in a list way. So it is presented in the front end or the client as a collection of different elements. This is done reactively. So in this case, because it's a list, we do not need to use a suspend keyword. It is the stream itself, the flow is itself already comprises coroutines. We can have a look at why is this. Let's go into the implementation. And when we look at this implementation, we see a couple of interesting things. We see my flow, we see collect. Here we can't really go in because we are, if I'm not mistaken, we are already inside the JVM. So here we can't really go in anyhow, but we can go a bit through the documentation it has. So if we go all the way up, and the signal on the screen sequentially emits values and completes normally with to meet operations such functions applied. Let's quickly sit on the call flow property, term operation flow. Flows are sequential and all flows are executed sequentially the same coroutine. There we go. So what's important here what stands out in this whole definition here is that by default flows are sequential and all flows operations are executed sequentially in the same coroutine, which with an exception for a few operations specifically designed to introduce concurrency into flow execution, such as buffer and flat map merge. See there the documentation for details. So essentially what we are getting here, what is important for us to know while we're building the application, is that flow will that the use of flow comprises the usage of coroutines in order to build a list. So we are going to use the database in a reactive way, and we are going to build our list in a reactive way and return it back to the client in a reactive way using coroutines. How exactly it's made is not really the subject of this presentation, so we can skip that, but keep the notion that when we are implementing reactive applications with coroutines, we use suspend function for individual instances and flows for multiple instances that we want to give back to the client as a collection. So this method is still not in use, and that is because we need to add it to the controller somewhere, and the best way to use it in this case is using a get request function get all spot on, and we're going to just return all elements that reside in the database. What else do we need to do? We need a put mapping which will essentially allow us to modify our spot on. So we have here the request body, we have a spot on DTO, and then we have a spot on service, and we can use the same upsert method because of course we said the upsert method will be used for a spot on and can be used to create a spot on article or to simply update it. So having said this about the upsert, I'm afraid I've just ran out of time. So this video is already taking 30 minutes long, and I think now it's the right time to stop and continue on the second part of this video where I will discuss the database, upgrades, the necessary changes in the schema, and how can we finish the rest of the remaining operations in CRUD. How do we define a primary key in the code, if that is even necessary? So whether you enjoyed or did not enjoy this video, I really want to hear your opinion in the comment section below. That will help me make the second part of this video even better, because the second part is actually very, very important, because it is the finalization of this application. In the meantime, I have made the application available in my repo. I have everything written down in the description below. You can read it. You can follow the development of this project. I will tag this first part as 000. If you check out this tag, you will have the code that has been developed up until the end of this video. You can continue following the code for future videos that I will make. Alright, that's it for this video. Thanks so much for watching. I hope you enjoyed it. See you in the next video, and until then, keep it graceful and stay sharp.